this question, similar to the previous question, is asking us to do an analysis of our function. And in order to do that analysis effectively, we need to look at the different parts of our function. Again, here it says, oh, find the zero, vertical asymptote, removable discontinuity, horizontal asymptote. No, we don't want to do that all in that order. If we find certain things at different times, that's okay. And so let's start off just by looking at this. F of x equals. Well, I see x squared minus 2x minus 8. I know that for these types of questions, I want to factor, so I'm going to factor here. X squared minus 2x minus 8, we've been practicing our factoring, so I know that that is going to be x minus 4, x plus 2. Because negative 4 plus 2 is negative 2, that's what we want, and then negative 4 times 2 is negative 8, that's also what we want. And that's divided by x plus 2, x minus 2. X plus 2, x minus 2. Now, do we see anything that's the same on the numerator or the denominator? I do. I see this x plus 2. Because of that, I know that they can divide out, and so I'm left with f of x equals x minus 4 over x minus 2. But we can't just take something out like that. We have to be aware of what that means. Now, I know that since it is x plus 2 and x plus 2 is the same thing, remember when we cancel something like this, we call this a removable discontinuity. This is something that would cause an issue in the function, but we took it out. And so we say there is a removable discontinuity when x plus 2 equals 0. But if we subtract 2 on both sides, we get x equals negative 2. Is that removable discontinuity? Let me do this in a different color. So here, we can just circle this. So that's one of the things we were supposed to find, the removable discontinuity. All right. Now, we have this function. Well, from here, we can find the 0 and the vertical asymptote pretty easily. In order to find the 0, well, we set the numerator equal to 0. So 0, x minus 4 equals 0. And then we add 4 to both sides, so x equals 4. Okay, so we know that's the 0. We can box that in. That's an answer that we have. And then we also need to find a vertical asymptote. And I know I can do that by looking at the denominator. So in order to find a vertical asymptote, I want to look at the denominator and when that might equal 0. The denominator here is x minus 2. Well, if x minus 2 equals 0, when does that happen? When x equals 2. Also here I should note, for the 0, we're looking at the numerator. Okay, let's get a third color here. All right, so we found the vertical asymptote, we found the removable discontinuity, and we found the 0. But there's one more thing we need to find. We need to find that horizontal asymptote. How do we do that? Well, for horizontal asymptote, we're looking at end behavior. What happens at the very end? Here we have f of x equals x minus 4 over x minus 2, right? And we only care about the leading terms. Well, here both the leading terms are just x, so we get that approximately equals x over x. If we divide both of those, we get 1. And so that means that our horizontal asymptote, I did not write that here, horizontal asymptote, our horizontal asymptote is y equals 1. Remember, for a vertical line, it's going to be x. For a horizontal line, it's going to be y. And so here, what is happening? Why is this not working? Oh, there it is. Here, we now see we have our horizontal asymptote. And so we were able to find all 4 features. We were able to find the removable discontinuity, the 0, the vertical asymptote, and then the horizontal asymptote. Did we go in order of these? No. We started with the removable discontinuity, and then we went up to the 0, then there, and then there. Just go in the order that makes sense to you as you're solving out this problem. Now, the question allowed us to look at the graph just to check our work, so let's do that right now. Let's see if we were right. And look, at -2, there's a removable discontinuity. We see that right here. There's a hole. Also right here at x equals 2, is that our vertical asymptote? Yes, it is. Here we have our x equals 2 line. Y equals 1, that's our horizontal asymptote. That's what we found. I'm going to put little checks so we know that those are true. We're seeing that on the graph right here, y equals 1. And the last bit is there a 0 at 4. Does the graph hit the x-axis at 4? Yes, it does. Right there. And so we verified that our work was correct. You can always do this. Try out the function and then test it out on Desmos. Type it into Desmos and then see, oh, did I get it right? Am I missing something? What's happening? What do I need to do right? Let me know if you have any questions.